We are here to attend the session, How to Build Your Data Engineering Profile by Anju Mercian. A quick intro about her. After completing her master's in computer engineering from Syracuse University in New York, Anju has worked for the past 10 plus years in various units of the software industry. She has been a software engineer, infrastructure engineer, project manager, business analyst, and product owner. Currently, she is pursuing her passion for data and is working as a data engineer for a social media company. Anju, I open the floor for you.
Thank you so much, Mansi. When you say 10 plus makes me very old, but here I am. Thank you all for joining my session on how to build engineering data engineering portfolio. My aim when I created this submit for this talk was to actually give everybody kind of like a template that will help you through a project of your own when you are creating a data engineering project. So this is my website. So if anybody wants to connect with me on LinkedIn, I would be very happy and excited to connect with new people. You can my details are there, so you can join me. And also, if you have any questions after this, also you can DM me on LinkedIn. I'm very active on LinkedIn. So the agenda for today is first I'll give a little bit about me. Mansi has already said a lot about me, but I'll just go a little bit about me, and I'll be talking about what is a portfolio project, what are the benefits of the portfolio project, data engineering. Like, so if you're new to data engineering and wondering what data engineering is, I'll just go a little bit of the definitions and who's a data engineer. Then I'll talk about the technical skills not just for the project, but will actually also help you as a data engineer. But also for the project. And then the steps, this is where the meat is. We'll talk about the steps that will guide you through the project so that will help you out in creating your own project. There's just like a guide that, like you can follow. And I'll also go over with my project what I did. Sorry about the noise. The project I did alongside with the steps, so you can get an idea. And also, Mansi will be sharing a GitHub link, which you can also go through with the project and create your own. Then we'll talk about some references. Then we will move on to closing and Q&A. So Mansi will be taking care of all the questions, and at the end we'll answer all the questions after the thing is done. So about me, I'm Anju Mercian. I graduated from Syracuse University with Masters in Computer Science. I have worked for Intel. I worked 5 years in Intel, VMware, Intuitive Surgical, and then recently, before joining Meta, I was working for a startup, volunteer-based startup called Omdina as a platform engineer. That's where my data science skills and data skills were put to use, and that's where my passion for data was ignited. And then now I'm working as a data engineer, and I'm just loving my job because I love being in the data realm. Okay, so moving on to what is a portfolio project. So what is a portfolio project? The portfolio project is basically a well thought out capstone project that will help showcase your skills to the potential employer or to anybody else, or to even to yourself. Say, hey, I know this. So that's what a portfolio project is all about. The benefits of a portfolio project is, one, you can get to showcase your skills. But if you're actually new to any domain, right, like for example data engineer, that helps you learn skills. So when you're thinking about the project, going over these steps are usually generic for any project. So if you're doing like a front end project or a back end project, this will kind of also be a template for that too. So this helps learn new skills. And then if you are once you find a job, or if you have a job, right, having a portfolio project usually helps as developing it as a side project, which like kind of I am currently doing. I'll work on the project, and you can keep up your skills, so because when you're doing a day-to-day job, you don't get to learn new skills. You don't get to learn new skills, but when you have working on project, especially for data project, what happens is most of your code and your data and everything might be private because of privacy concerns. So usually the companies don't like to share their data. So now when you work on these side projects, you usually work on public data sets. So this will help you also showcase your skills, then build a personal brand. what so if anybody is looking for what you do, it helps build a personal brand. And also one thing I found out from personally is this helps with data design interviews. Like if you're looking at a data engineer and you build a data engineering portfolio project, that actually helps you in data design interviews. So here I'll talk further on, I'll talk about how to think about building a data model. Building a data model actually helps you with design-based questions when it comes to data engineering interviews. So you'll know when they ask about when they give you some tables and say, "Hey, can you build this out?" Working on the project would have actually given you an idea on how to build it out. So that's the thing. Now, moving on to what a data engineer is. So, what is a data engineer? So, data engineer is somebody that takes raw data. So many companies are collecting data. Data is being collected everywhere. Everything that we do on a mobile, on laptop, they're collecting data. That's where the privacy issue comes, like laws like GDPR is in place so that they don't collect a sensitive information, and all the companies are on track for that. Desensitizing all the companies. So basically, all these data is collected. Now, the role of a data engineering, the role of the data engineering position is to basically take all of the raw data and showcase it as a usable data, right? Build it into better tables for business consumption, or for data, or for a data scientist, or for an ML engineer. The person between the raw data and the ML engineer is the data engineering person. And who's a data engineer? So you are the data engineer, who you're the one who builds systems, who build pipelines, or converting the raw data to usable data. So that is a data engineer, if you're new to data engineering. Okay, so let's go over the technical skills here. The most important technical skills for anybody in the data sphere right now is SQL and Python, and even for a data engineer, it is the same. And most of the time, not only for creating this project, but even in interviews, SQL and Python are the first technical questions that they ask before you go into the next round. So first round is technical round, and all of the questions actually will be based on SQL and Python. So having these two skills is very, very important. Um, it's not difficult to learn, it's easy to learn, but it's an important skill. And then we have I've written only AWS is the cloud based architecture, but you can also have GCP, Microsoft Azure. You have open source, many open source cloud services, but I like AWS because it's easy. It's expensive, but for one time thing, it's okay. But we need to make sure we are very careful in shutting down all the services, because otherwise they charge you. Once I was charged a lot of money, I was like, what is happening? I never used AWS, but they charged me money. That is because one of my instances were open and I forgot to close it. So that is one thing with AWS, but it's very easy. I like it. It's like click, click, click. You can actually have code-based notebook. I think even GCP has that code-based notebook that can help you create your S3, load data into S3. S3 is actually the storage. Redshift is for analysis. EMR is also for your data engineering needs. You have free tier where you can try it out. And also, so that's what AWS is all about. Apache Airflow. So Apache Airflow is actually something called a DAG. We'll talk about all of this in the upcoming slides. So what does that DAG do is it helps you streamline your ETL, your data pipeline. So you can automate your pipelines using Apache, like Apache Airflow. Like Apache Airflow, there are many different DAGs that be used in companies, but Apache Airflow is free and available, so you can go and take a look at it and learn it. So this will be a good skill to have. Now, all these AWS, Apache Airflow, and PySpark helps you kind of helps you one up yourself, level you up. But SQL and Python and data modeling, those are the critical skills that you need to have. All of this is additional skill which will give you your resume, will help your resume stand out. So those are the skills. We'll talk about these in the upcoming slides. And the last one is actually PySpark. So Python and Apache Spark language, it's PySpark. That can also be used, and you can do all your data wrangling using Spark. Okay. Okay. Now here, first let me do one thing. Let me guide you through the steps, and then we'll go over the GitHub link of the project. So what are the project steps? Now, this is usually what a company does. what a company first does is they'll scope the project to the stakeholders, then they'll gather the data, they'll explore and assess the data, then they'll define the data model, then they'll run the ETL pipe, then they'll run the ETL load, like ETL is extract, transform, and load. So basically, they take the raw data and or data from different formats like a CSV or Parquet, SAS. All of these formats. You may find data in all of these different formats. Take um, take the take the take that so combine all of these different data sets and create like one set where people, it'll be easy access to for people. That's something they do. Then you create data pipelines and you schedule them to run. This is where you'll use something like an Apache Airflow tool that will help you automatically run and streamline your pipeline and schedule them. Then you build it out to a dashboard, usually like a Tableau or a Google Studio. And every company may have their own. Smaller companies may depend on Tableau, bigger companies will have their own. And then you repeat it for another project, right? So this is the kind of the template we're also going to follow for our portfolio project. I know, like, you're not talking to stakeholders, you don't have to, you may not have one, like a lot of data in petabytes, but this will be kind of helpful for us to when we are creating our portfolio project. Okay, now, so what is scoping the project? Here, this is where you have to decide what are you planning to do. Like, what is your goal for the project? What do you want to showcase? What like, for example, in my project, what I've done is I've taken the US immigration data, the demographics of the US immigration data, and the temperature data sets, and I'm trying to answer the question, what kind of demographic statistics to which immigrants move to of US cities the immigrants are moving to, or like, are they moving to warmer or cooler weather? These are the two questions that I'm trying to answer with my tables or with my project, right? That's so what I need to do is now, okay, this is either you can either see the data. Sometimes you can there's actually also a Medium link that Mansi will share towards the end, which is where I have shared a few ideas on data engineering projects, and all of the places where you can actually go and get free data, which help me. So you can actually look through all the data. For example, like airline safety and weather data, right? So like, if the weather is bad, are airlines safe to travel? Those are some of the project ideas that you can look at. So crime data, you can look at crime data and say crime and property data and say, oh, okay, so so we know these are questions that can be answered, like, yeah, high crime data, you're not going to go live there, right? But with you can prove this with data, right? That those are some of the data engineering project ideas that you can work with. But first, you need to write down your goal for the project, your like a business requirements. Like in companies, they have business requirements. Write those as business requirement for your project. So these are the requirements I'm writing, so that at the end of the project, you can actually compare. You can answer these questions using your data, and that's very important. You need to you need to turn the full circle and come back to answering these questions. That's when your project is actually successful. So you need to build it in such a way that you're doing that. And then there are different types of ways that you can create a project. One, you can create it as like data warehouse, where people can where you're taking the raw data, cleaning the data up, putting it in different tables and storing it in a data warehouse, and then people can, so the data analysts can go and gather the data and use it. Or you can build it as a data analytics table. So my idea was to just build it out as a data analytics table, and that's what I'm doing here. So now I've scoped the data and I've gathered the data. So these are all the data sets that I gathered. Then I will show you my GitHub. I'll go and assess the data. Give me 1 second. I'll unshare and reshare. Sorry about that. Okay. Okay. So this is my GitHub. Mansi has already shared the GitHub link. It may be all over the place, but I have followed this. And here, so what I've done is I've gone over the immigration data. My immigration data set was my largest data set. It had more than 3 million rows, like if you see here. It's always good to have one data set as has more than 1 million rows to showcase that you can handle big data. Like also for like portfolio project, one thing I wanted to add is when you're working through these projects, when you're working through a portfolio project, you can actually answer the question when they ask when they ask you behavioral round, when they ask you a question like, have you worked on a project that has been very difficult for you, or the challenges you faced in the project? So if you've not worked on a data engineering project and you worked on this portfolio project and you face these issues with using high volume data, like, yeah, this is the issue I faced. I had this high volume data. This was raw data, which I had to clean up, and that helped me learn further on how to clean up data, and that was very useful to me. You can answer those questions, so this will help. So this is one of the things I said to my interviewer. So in this, and there are like a lot of columns. If you see, this immigration data set was huge, and lots of unnecessary columns. Sometimes it's like I didn't want the occupation. This was also a null field, so I'm like, I don't want the occupation. You can draw when you're that'll be when you're defining the data model, but now you're exploring and you're like, okay, there are so many rows. Do we need all this? Now you need to go and find out also what these mean. Sometimes they have data dictionaries, sometimes they don't have data dictionaries. So you're like, okay, you need to go find this out. So this is where you explore the data, and then you can find out like how many nulls are there. So if you see there are so many nulls, right? And you can also decide what you need to do with the nulls. Do you want to delete it? Like, do you not want to delete it? Like I chose not to delete it because if you see the CI/CD, which is the primary key, which is the key for every immigrant that has come in with this data set, it's not null. So that's why I chose to keep all of the others. And if they were not useful, I just dropped the column. I dropped the column when I was creating the table, the tables for my analytics table, right? So so you take a look at that, and you explore the data. I'll come to this. Then you explore all the different three. I have three, and I explore them. I will go over them. One thing I actually wanted to mention, which has helped me, where I learned something when I was reading something, I read, try choosing non-Kaggle data sets. There are many different data sets available, public data sets. They may be difficult to work with because they're just public data sets available. So that's actually challenging. It will not be clean, but usually most of the Kaggle data sets, one, it's used all the time. Two, it's mostly clean. So you're just like, and so you may not be able to impress the interviewer, especially if the interviewer is really, really technical and has worked on Kaggle before. They're like, Kaggle data set, maybe like that. But if you work on public data sets, at least one, data set which is public, and then you have struggled with it, it's one, you learn. That's my personal opinion. One, you learn a lot when you struggle with something, and two, you can actually showcase that, hey, I have the ability to work on my own, work on a data set I'm a self-starter, self-motivated person, all the strengths that we need to talk about. So that will help. So that's one thing I wanted to share. So you explore and assess the data. Now, this is where most of the time will be spent in defining your data model. So what is a data model? Data model is where you design your data. Now, I have all these tables, and these are the tables that I have. These are the requirements that I want to fulfill. Okay, and there are also requirements for a data set. For example, like joins are expensive. So you need to make sure that even in companies, you need to make sure that the end person that is looking at your data, or even it may be you too, that you're not doing too many joins. Whenever there's a join, it's actually taking up a lot of performance time. Like if it's a smaller company, it may be more issue than a larger company. Larger companies may have the bandwidth, but you should always be careful of the performance issues. So you should always be, so those are performance issues, integrity issues. Those are like the three things that you have to think about. So you have your data set. Now you need to figure out how you're going to answer the question, and how are you going to make sure that you are following the database integrity rules. That's what you do here. You're defining the model. So when I looked at all of my three data sets, I was like, okay, I'm going to have do something with it, right? Let me split it into fact and dimensional tables. Now, this is very important to know as a data engineer. You need to have like a fact table and a dimensional table. Fact table is basically contains the facts, as the name says. Fact contains more of the statistics, more of the numbers, and also the primary keys to other data sets. So if you see over here, you have primary keys to other data sets and more of the facts of the immigration. So this is mostly concentrating on the immigration, so the fact of the immigration. Here I've also kept visa, because visa is usually a personal information, but here in this particular table, visa will be a fact, because I'm looking at the immigration. So what kind of visa, people with what kind of visa coming into the US, right? So that information can be found out from the fact table. That will be a fact. Now, what is a dimension table? Dimensional table contains the characteristics, right? So your age, your gender, if the personal dimensional table, your age, your gender, your address, the city you're coming from, the state, and the dimension of temperature will be like how hot it is, how cold it is for a particular day, and your latitude, longitude, all that will be the dimension table. So that's what a fact and a dimensional table is. And here I've chosen star schema, one, because my data set is very small. Usually in companies, you can use a snowflake schema when you have larger joins and larger data sets and many different questions, business questions to answer, right? So you have snowflake schema. Snowflake schema is nothing but different star schemas attached through one table. That's like, and then you have, it's like a snowflake. You have one star table, different star tables, and they're connected through another fact table, So multiply this with another fact table, that's a snowflake schema. But here I've used something called a star schema. It's named such because it looks like a star, and then snowflake schema because it looks like snowflakes. These two are very important, and then you have to like work through the different models, like conceptual model is where you are actually designing all this out, all your primary keys, your foreign keys, you're keeping your atomic atomicity rules, all that. You're deciding that in conceptual phase. Then there is a different phase called logical phase and physical phase. So logical phase, you're doing all of the logic behind all of the tables, and then you physically do it. Now this is where I'm physically doing it. So if you see here, I'm actually creating as a data frame, which I'll convert into table later on. Here I'm just creating as a your production code will not be a notebook. It will be in like Python code on your Airflow DAG pipeline. So, but here I'm just creating it as different data frames, and I'm splitting it out. I'm taking only the columns that I've decided over here, necessary columns I've decided over here, putting that in here, and exploring the data here. Now, okay, so I've done that for all the three. And that's what you do in the data model. I hope I'm sticking to time. So that I do that there. Then you run the ETL pipeline. Basically, all of this, you put it into functions here, like how I created over here. You create it into functions so that you can just send it in and put it into like the pipeline, the Airflow like pipeline. Usually, most of the time, companies have pipeline, but if you are doing your own portfolio project and you're not doing anything like Airflow, you'll just have it as your own function here in a notebook or wherever you're working on. So you're modernizing the function, the cleaning steps, you're creating the fact and dimensional tables, you're doing the data quality checks here, and then you're creating the data dictionary. All that is happening here in this run the model. Then you deploy it. You either deploy it on a free dashboard that's available through Tableau, or you can deploy just on GitHub, like how I have done. Now, this is the basic. So this shows that you know data engineering, you know how to deal with data. This will help you create a basic capstone project. Now, how can you showcase your skills to stand out? How can you make this better? Is through this. So one, data quality. I know I said you need to have data quality, but explaining or emphasizing on data quality is very important. Like basically, like does the data have certain size? Data quality is actually important even when you go into companies, because when they give you a pipeline, or when a dashboard is given to you to take care of, you need to make sure that the data that you have over there is quality data, right? So is the data of a certain size? Is it of is like free of this small, there'll be errors, but like margin is small. The data arrives on time, so they should, when they open up the dashboard, and top management opens up the dashboard, it shouldn't take too long. It should be on the circle for too long. So you should make sure of that. Why is it taking too long? And then you should have your pipelines running on a particular schedule. Data must not contain any sensitive information. That's very important. And if you have sensitive information, I know you'll have to go through a lot of stuff to make sure of that. And my data quality details also here. If you want to take a look at it. So I was doing, because this is the public data, and this was like my thing. The only things, most of the things I checked was integrity constraints. Basically, are the primary keys should never be null. So I need to make sure my primary keys were never null. And so that's something I'm checking. I'm making sure all the scripts run, all my tables are filled. My table shouldn't be empty, right? So I created fact table, dimensional table, all of the tables I'm checking to make sure it's not empty. And then making sure the completeness of so whatever I created and defined the data model stage, it's all complete. So that's a check I'm doing. And these are some of the checks that you can do too, but make sure that when you want your project to stand out, you are showcasing that you know what data quality is and you can handle quality data. Okay, and then we have Apache Spark here. Or you can also use Apache Spark to do your data wrangling. It's a new language, but it's easy to learn. It's same as Python Pandas. The same thing if you see the syntax to be like almost the same. You just have to use call-in functions to do that. So you can do it for a few. Like for my immigration table, this is my immigration table Spark session that I have created. You can use Spark, Apache Spark. And DAG. So DAG is basically your data pipeline, so your series to create your ETL steps, and DAG helps automate those steps. Apache Airflow helps automate the steps. So if you see over here, you can create your different, like clean the pipeline, create your tables, all this as like a DAG. Or your workflows or different functions, and then put it into Airflow, and they'll run it automatically for you at a schedule that you say, maybe daily, night at 11:59. Go into the raw data, take the raw data, clean it up, make sure it's clean, create the fact and dimension tables. Now, once you have done this, it'll just go and update it every time. So you won't have to run again and again, creating the whole thing from scratch. You'll just keep updating it. So that is also something you can tell the Airflow tag. And that's what Apache Airflow is, right? Okay. And I have that there. And cloud deployment, doing it on cloud, it'll be great if you can find one Amazon free. Everything has a free tier or a student tier. You can try using that depending on what you like. You can choose the three. I like Amazon personally, so I usually use AWS. And I think that's it. Towards the end, Mansi, how am I doing on time? I think I'm a little over. Mansi?
Hi, Anju. No, you're doing perfectly fine.
Okay. So I'm almost towards the end. So in closing, I just want to say that these are the project steps. So follow these project steps. This is just to help you follow certain steps as templates so that you can base your projects on these templates and help you through a project. I have a Medium article that will give you, and I also give you a few more ideas and also public data sets. Amansi has already shared those, and you can go and take a look at all of those data and work your own. All the best to everybody that wants to work on a project and become a data engineer. It's a great place to be if you love data and being a data engineer. I like this space. I actually wanted to be an ML engineer, but I like this space more. So currently here, maybe I'll become an ML engineer later, but I like doing this right now. So time for Q&A. Thank you.
Yeah, that was a great session, Anju. We have a few questions for you. So one is, when you need to create your own data dictionary, is there a standard format that it is expected to be in, or it can be any general format?
Actually, data dictionary has a format. So actually, I have it over here. So basically, you write the variable, space, and then the explanation. So you write it in a table that says the variable or the column name and the explanation of what it is. Like for mine, the CICID, primary key to identify an immigrant. some like that. So that's something you should usually follow.
Okay. So next question is, how can we find public data sets? Is it in a specific place or do we just search what we need on Google?
Yeah, actually, the Medium article that I have shared, and also I'll share this presentation afterwards. I have shared links. There are a few sets like UCI machine learning repository. Then usually every city, like San Jose City, has their public data sets. So San Jose public data sets, if you share, you will have public data sets. And I also have shared links. So I think 30, 50, 30, 530, something like that, 530, they also have all the links of where you can find public data sets. Almost all companies give out their public data sets, but they're always scattered. Like people like them have 530, they have accumulated all of that. And GitHub has a repository. So GitHub repository of free data sets. Google data sets is there. That's also public free data sets. So,
Okay. Next, what are the benefits of Apache Spark over Pandas?
Apache Spark is actually beneficial only in big data. When you have distributed data, when the data is way too large, Apache Spark can help like parallel processing. So usually Apache Spark helps only in big data. Apache Spark is actually built for big data, like Hadoop. There was the Hadoop and Hive and Pig. These are all for big data. Apache Spark is the latest technology that comes into addition for Hadoop and Hive. That's a good question. Thank you. I forgot to cover it here. Apache Spark is actually for big data analysis, but you're showcasing it here so that you can showcase that, hey, I know Apache Spark and how wonderful it is for distributed processing.
Okay. In terms of data ops, what new tools might be useful to monitor the quality and lineage of data?
For example, this Airflow Apache DAG will be very helpful. And when you are using one of the clouds, AWS, GCP, and Azure, all of them have, like for AWS, there's Redshift and EMR that will help analyze the data lineage. They have a very good visualization as to showing you how the data lineage is, so you can easily visualize it. And even DAG will help you make sure that all of your pipeline runs properly. They have a beautiful diagram that they'll show you, visualize for you. All of the cloud has that. And these are the Microsoft Azure is actually current latest technology that's use, and GCP and Amazon keep updating it, but Microsoft Azure is latest that's being used right now.
Okay. Also, what tools do you currently use the most? Like you have been talking about AWS, so any favorite tools within AWS?
So I actually currently working, like for me personally, yes, I'm using AWS. I'm actually learning GCP and Microsoft Azure to move to them also to try and change to them. But since I'm so used to AWS and continuously, it's easy for me to go. I know exactly what to do, so I just do that. But I'm trying to shift to GCP and Microsoft Azure and use that. But since I work for like a large company, they have their own technologies and tools, which I can't talk about right now, but they have their own technologies and tools, just like this, but it's a different, their own in-house. So.
Okay. Also, how do you formulate a problem statement for data engineering projects? Like if we start on our own, how do we settle up on the what answer this project would deliver? What question this project would answer?
So it's basically your intuition, right? So you, like, for example, you're living in this world, and we had coronavirus right now, right? So you can be like, okay, how many people lost their jobs in coronavirus? These are the questions. Sometimes these are the questions that you keep asking yourself, right? So those questions you can kind of divert them into like trying to find the data for that and divert them into kind of goal orientation, right? Companies have their own, that's how they have the intuition, right? They learn what's going on and how to better their tools and how to get better analytics of how their tools are doing. The same way, you can also ask your own self these questions. Like, for example, crime data. That's something when you're buying a house, you look for that. Or when you're looking for a house, you want to like look at Zillow data and the public data available in houses to see how the house is doing, how's the market doing. Many people are interested in stocks. Those interested in stocks can look at the stock data. That's one of the most used data, most used machine learning data is stock data. So that is there. You can look at that. So basically, you answer questions that you have questions about. That's like intuitive questions. So.
Okay. How long did it take you to build this project that we just had the walkthrough to?
I took like 1.5, 2 months, because while doing this project, I was learning through data engineering too. So this helped me. So 2 months with a full-time job. So.
Okay. And what prompted you to switch your journey to data engineer role?
So I because since machine learning was so much talked about, I started taking Andrew Ng's machine learning course, and that's what actually I always had interested in SQL, but there was no much jobs when I was like studying. It was only a data administrator job, and I really didn't want to do that. So that's why I was trying software engineering. But when I heard about this data engineering, when I started taking courses and learning more about machine learning, I came across this data engineering. I was like, this I can do a lot more SQL, and I like Python. I like the language Python. I like SQL, working with SQL, working with data. So I was like, okay, the passion was ignited.
Understood. Okay. Any more tips for people who are just beginning with it to understand how to build a project?
I'm hoping this template will be helpful, and also you can go through my project, and hopefully that will be helpful. Like most, just start with a data set. Like start with a data set, look through the data set. Just use the pandas commands like dot read if the CSV file dot read CSV. Look at the columns. Try to see the null. Just do the basic. And then try to figure out, hey, will this data set be useful to me? Can I answer some questions? I started with looking at the property data set for New York, and then I was like, how much crime is there? I should be worried about crime, right? And then I was like, okay, let me go do the crime data set. And that's how I started joining tables and data sets. So just learn the basics of Python. If you're new to programming languages, just basics of Python, just start delving into the data set. When you learn swimming, they say push you. I don't know if it's a great idea or not, but they say push you when you start swimming. That's how this project is. Just push yourself into this project and learn. It's going to be challenging, but just keep swimming and learning. Keep your head up. Keep your head above the water. That's it.
Okay. Yeah. Thank you so much for all the great tips that you've given. I hope it helps everyone.
Yeah. Anybody has more questions, please contact me on LinkedIn, and I'll be very happy to help. My email is there. You can contact me on my email. I will be very happy to help anybody. Thank you. Thank you for having me. And thank you, Mansi. You're a great moderator.
Yeah.
And thank you, Stephanie.
Thank you so much.
Stephanie is my mentor. So thank you, Stephanie. And thank you, everybody, for joining my session. Hoping it is helpful to everybody.